Okay, so this section says properties and laws of logarithmics. So remember, logs come from exponents. So let's make sure that we remember our exponential properties of product and subtraction and multiplication and division and so on and so forth. Because there's a product property and quotient property, and there is a relationship between log and exponential. So I want to make sure that we remember this. So you have an x square multiplied by x cube. What is the result of this? Anybody? We should all remember this. X to the 5th power. Perfect. Why? Because you add the exponents. Whenever the base is the same, you add the exponent, right? This is one property. The second property is, what if you divide x, same x, you have 5 at the top and you have 2 at the bottom. What's the result of this? Again, anybody? Subtract. Perfect. Awesome. Good answer. Okay, so this is your addition property, this is your subtraction property. When you have the same base, you add the exponents. When you have the same base and it's dividing, you subtract the exponents. Okay, let's see how this converts to our logarithmic thing. So if you have, so this, the first property is product property. When you have an input for log which are multiplied, it can be expanded as log, the base has to be the same, of m plus log base. So do not forget that they have to have the same base, because sometimes they'll try to trick you by putting different bases and ask you is this right or not. So you have to have the same base, but it becomes m plus n. Because it is remember, multiplication converts to addition and division converts to subtraction. So this is the product property, and this one is going to be same base and two elements are divided. That means you will do log base b of m minus log base b of n. So same concept. Division is subtraction and multiplication converts to addition as long as you keep the same base. As long as you keep the same base. And then there's one more property, power property. The power property is whenever the input, so remember this is the input for log. Whenever the input for log has an exponent, the exponent moves to the front. The exponent moves to the front, meaning this can be rewritten as n multiplied by log b of m. Log b, log b of m. So whenever log has an input which has an exponent or which is a power, the power moves to the front. It's the same thing, n ln of m. It's the same thing, whether it's ln or log base b or just log base 10, anything, it's always the same. Okay, we'll see how we'll put this in actual problems. So, and you see these are properties we are learning, but we're actually working towards the next section, which obviously we're not doing today. The next section is solving log an exponential equation, and they will use all these properties. They will use all these. So we are ultimately, our goal is to solve an equation. And solving an equation, we need to know these properties. So that's what we're getting towards. So we're going to practice some of these properties, see how we're going to put this in practice. And when we actually get to solving a log and exponential equation, it will be easier for us because we've practiced this. Okay. So the first thing it tells us here in example 1 is to expand the following logarithmics. So a lot of times when you try to solve, it helps when you expand it because it makes it easier for us to solve. So why are they telling us to expand it? The input for log has 3 elements. It has a 4, it has an x, it has a y. And it's telling you to expand it. That means I can write them as 3 logs. 4 and x are multiplied, y is divided. That means this can be written as, my base will always stay log base 10. 4 and x are multiplied. So you'll write log base of 10 of 4 plus log same base of 10 plus x. So 4x can be broken down as log of 4 plus log of x. But y is in the denominator, y is subtracted, so you'll do minus log of y. This is your expansion. So you see how you can actually solve for log of x. It's easier because if x is a value, you can find the value of log of x, if y is a value, and then what's a log of 4. Okay, can we all try to do b without my help? You have to be a little careful about keeping the 3x squared together. Everything in the denominator needs to be subtracted. So what I'm going to do is log, the base is the same, 3 plus log base 7 of x squared. For now, we'll open it up later. Everything in the denominator, and in the denominator 3 and x squared are multiplied, so in the denominator, but the whole thing is this statement making sense? Log of y is written in the numerator minus everything in the denominator, but I'm also expanding the denominator to a certain extent. So now I want to open the parentheses and write the whole thing. I also, remember, we also used the power property, so the 2 should actually come to the front. So my final answer will be log base 7 of y, nothing happens to that, minus log base 7 of 3, nothing happens to that, and the negative gets distributed to the second term, so that becomes negative, and you want to move the 2 over to the front because of the power property. This is your final expansion, which you could have done in this first step itself, but I just want to make sure that you understood why the second term is also subtraction, because it's in the denominator, and the 2 should be moving to the front because of the power property. Okay, can we all do C? See, not only will you expand it, one part of the expansion you'll actually be able to evaluate, and I'll tell you what that means. So why don't you do at least the first step of expanding it. So remember, every element multiplied, multiplication or division converts to addition and subtraction. Everybody okay so far? What is log base of A? Can I evaluate this? Can we all evaluate this? This is evaluatable. 8 to the what power gives me 64. Basically, that's how you read it. What is log base 8 of 64? This has a value. I'm going to rewrite it as an A. Please solve for A. And that's what you'll write here. So whenever you have an expression in the log that is evaluatable, you should evaluate it. So what is log base 8 of 64? 8 is my base, A is my output, becomes my input, is 64. 8 to what power gives me 64? Correct? That means the A equals to 2. That means this is equal to 2. So that's why I said part of the expansion is evaluatable, so you should evaluate it. And then in this case, the only thing I need to make sure is I move the 2 to the front. So it's 2 log 8 of x. That's my final answer. If you don't evaluate it, I will take some points off, because if you see something, especially something as obvious as this, 8 and 64, you should see the connection. 8 squared is 64. Okay, I'd like you to do D again without my help. I'll leave this on. For those who got this, please do D. And okay, removing this. Sorry. So now we're all looking at D. D is log base 3 of 9 x to the 5th power. Nine x to the 5th power is the input for log. Okay, so let's go ahead. Please go ahead and expand it. So we're all working on D. So there are two elements that are multiplied to each other. Everybody good? You can separate them with an addition sign. You can separate them with an addition sign. Yeah, is that making sense? Is that kind of, are you able to guys put that together? That whenever you see an input for log which are multiplied, you can break them up as addition, separate terms. And if it's divided, you separate them by subtracting. So because there are two elements, so maybe it's a good idea just to put your symbols there. So you understand that 9 is an element, x to the 5th power is an element. They can be broken up as the addition symbol. So this can be written as log base 3 of 9. You're breaking it up, remember. Multiplication is same as addition in expansion. And then what is this? Log, same base, x to the 5th power. Except 5 will move to the front. We'll do that as the next step. Except, can we all evaluate what is 3, log 3 of 9? 3 to the what power gives you 9? We should all be able to evaluate this as 2. You can write this, if it's easy, go ahead and write this what I did last time, log base 3 of 9, call it A or B or whatever. Evaluate that A, write that down here, and this one is going to be, all you have to do is move the 5 to the front. But go ahead and evaluate this. I'll give you guys 30 seconds and then we'll go to another problem. Any volunteers of what we got for log base 3 of 9? What is this A equal to? 2. Perfect. Good answer. Everybody got 2? Does anybody need an explanation why it's 2? Okay, can I go to the next section? The next section actually tells you to condense. It tells you to condense. Why does it tell you to condense? Because look at the problems here. I have multiple log terms. And what do you notice? What's important is for you to be able to condense, they have to have the same base. If they don't have the same base, you cannot condense. So basically both these terms can be written as one term with a log base of 4. So I will write this as log base of 4. I can write them as one term. 32 divided by 2. Okay, this is an important step. This is a new step, new thing. Is this clear as to how I did that? My base is 4. So log base 4 of 32 over 2 because it's subtraction. What is 32 over 2? 16. Awesome. And what is log base of 4 of 16? Can we all evaluate this? 4 to the what power gives me 16? Yes, very good. It's 2. Because you can again set it to equal to A and do all of that. So this condensing helped because it allowed me to evaluate it. It helped because it allowed me to evaluate it. Okay, let's go ahead and do B. There's one more thing you have to do in B before you can combine. What do you think I should do? They do have the same base, log base 2, log base 2. But before I can combine them, I really cannot combine because there's a 6 in the front and 5 in the front. What should I do to those? You do the reverse of the power property. Remember, anything to the power, you bring it to the front. So if it's in the front, I should be able to move it as a power. So before you combine them, this should be rewritten as log base 2 x to the 6th power plus log base 2 y to the 5th power. Sorry. Is that clear? All I did was to move this as a power, 5th power. I hope this is clear. I scribbled a little bit. Now you can combine them. Now you can combine them. Same base of 2, log base 2, and go ahead and write the input. And that's it. There's nothing more to be done. Did everybody get this? I will be glad to explain it if you didn't. Okay, let's do C. And can I move to C? Okay, let's do C. So C is pretty straightforward. The input for ln is 5x. The input for ln is 3x with a plus sign. So I should be able to combine them as 1. How are we doing with C? Any questions? Okay, can we also do D? I just think the more we practice, the better. Let's do D also. Okay, so before I try to combine them, I need to move the 2 over, right? Otherwise I won't be able to combine it. So I move the 2 over to 6, so it becomes 6 squared, so that's what I get. Now combine them as 1 log, because it's a subtraction, that means you can divide the input. Yeah.
How did you get 36?
Oh, 6 squared. Because remember, if there's a number in the front,
Oh, right.
yeah, you just move it as a square. Yeah. Okay, that was a good question. Anyone else? And then, I'm not done, right? because this can be evaluated. 4 to the what power gives me 4. So my final answer is 1. You can basically equate it to A and rewrite it, and you'll get A to be 1. So that's 1. Everybody got 1? Yeah? Okay. Alright, let's keep. We'll do one more. The next one I'm assigning is a little long. It's longer than, and then just go ahead and, so we're doing E, but go ahead and scratch off G. G is I don't know what happened here. So you have this whole space to do the work. So go ahead and do E. It seems longer, but all the base is ln. So you should be able to multiply and divide. Except step number 1, make sure all the, if it has a coefficient, move it as an exponent. If it has a coefficient, move it as an exponent. That should be your step number 1. I will write the first step in 30 seconds. Please, you first do it. I will follow. Okay, so hopefully everybody got this as the first step. Okay, so now I should be able to write this entire thing as 1 ln, because all the bases are the same and they all have a subtraction or addition in between them. That means any of the elements that are subtracted will be written in the numerator. Anything that is anything that is added will be written in the numerator. Anything that is subtracted will be written in the denominator. So there's only 1 ln. The numerator will contain 2 cubed, because that's a plus, right? The front 2 cubed is 8, so I'm going to write it as 8, multiplied by, what else is plus? X plus 1 square. That's it, there are no more pluses. Over this is a 3x, sorry, I forgot the x. Over, both the subtraction go in the denominator, 3x, x minus 1. That's it. You okay? Okay, there's just, I know it's been a long class, there's just one more thing I want to teach. How do you actually use the find the log of something? So the idea is to use the calculator, but right now I will not we'll start the next class by using a calculator. What I'll show you is how to change the base, because our calculator, I'm just going to quickly show you this. Our calculator has only 2 bases. There's my calculator. Our calculator has only 2 bases, like I said. So there are 2 buttons here. There's log, log. There's the log, that's the only button, and then there is the ln. So if they ask you what is log of 5, you can use log. But what if they say what is log base of 2 of 5? You don't know what to do because you have only these two buttons. So there is a change of base formula. A lot of the advanced calculators, you can automatically do the change of base formula. Those with do not have the advanced iOS, there's a formula. We expect you to know the formula because you never know which calculator you will use. There will be situations where you won't be dependent on the calculator, so we need to know how to use learn change of base formula. Okay, so the change of base formula is here, right here. I'm just going to highlight it, but I'm going to teach you with numbers rather than with variables. As always, I prefer to do it with numbers. So I'm going to go to the next page and show you how to evaluate change of base formula. Alright, so it says evaluate log base of 6 of 15. So I'm trying to evaluate if they had just said log of 15, I could have used my calculator. If they had just said log of 15, I could have used my calculator. I would have just pressed log and input the input. But unfortunately, they give me a base of 6. Unfortunately, they give me a base of 6. So for you to be able to use log or ln, what you will do is you will rewrite this as log base of 6 of 15 can be rewritten as, now we're going to use, because remember my calculator allows me to use only log or ln. So I will say log, or you can use log or ln, and I'll show you both the formulas. It has a numerator and the denominator. Numerator will contain just the input. The numerator will contain just the input. Divided by the denominator. I tell my students that one of the easy ways to remember is the base comes at the bottom, right? So the denominator will contain just the base. Log 15 over log 6. Or, remember, you can use any base. You can also use ln as long as it's the same base, or this is how you change the base. This is how you change the base without depending on the calculator's advanced change of base formula. You can just do this. You can just do this. Okay, can we all rewrite log base 18 of 7? And give it to me in the log or ln. Or actually give me both. Give me both. So that you understand that you can use either. So remember, the numerator will contain just what's the input. The denominator will contain the base. The bottom will contain the base.